This is problem number 9 on the sample test problems for test number 2. A 12-foot long ladder is leaning against the wall, forming an angle of 73 degrees with the ground. Assume the ground is level and the wall is perfectly vertical. And then there will be some questions about this, but I feel like we need to start with a picture. So we've got our wall, we've got our ground, and then we've got a ladder leaning against the wall, which forms an angle of 73 degrees with the ground. So first question I'm asking myself, if I'm trying to draw this thing roughly to scale, is this ladder a quite steep ladder, or is this ladder a quite flat ladder? And so that 73-degree angle is made with the ground. So I want the angle made with the ground to be quite steep. So it feels like if that's the choice versus this one, well, the one that's big, 73 is pretty big. So we want the first one. So this ladder is quite steep. So let's draw something that's quite steep. 73 degrees there. And at what angle do the ladder and the wall meet? So I guess that's this angle up here. And I know it's a right angle, and I know that the other angles have to add up to 90, so this angle here must be 90 subtract 73, or 17 degrees. B, what is the distance between the top of the ladder and the ground? Okay, well, we have to know some distance in this problem, and we haven't yet used the fact that it's a 12-foot long ladder. So we'll label the hypotenuse there as a 12. And we want the distance between the top of the ladder and the ground. Top of the ladder and the ground. So that's this distance here. And what we have now is an angle. And with respect to that angle, this side over here is what we've been calling the opposite side. And the 12 is the hypotenuse. So we want the trig function that relates the opposite to the hypotenuse. And that trig function is sine. So in this case, we're going to use sine of the angle, 73, is the opposite divided by the hypotenuse. So the opposite, I can call this one over here, I'll call it y because it's a vertical thing. So the opposite is y divided by hypotenuse is 12. So multiply both sides by 12, and we get 12 sine of 73 is y. And then we'll go ahead and type this on the calculator and get a decimal. So 12 sine of 73 is negative 8.12. Let's see, what units are we in? I guess we're feet. So that ladder is negative 8 feet. Let's see, so the vertical is negative 8.12 feet. So we made a mistake here, at least I've made a mistake here. And oftentimes it's not as obvious as it is in this part. I mean, there's no way the distance here is negative. But you can get a quite reasonable answer that's just plain wrong because you've made the mistake that I did. And the mistake that I made was hitting this sign button without thinking about what mode the calculator is in. This problem right here is in degrees. That's 73 degrees. My calculator is not set appropriately. So anytime I want to hit the sine, cosine, or tangent, or the inverse trig functions, I first go into mode and make sure that I'm in the right place. So if we quit out of there, and in fact, I could just hit enter right now and it will give me the right answer. If you don't feel confident doing that, then just type in 12 sine of 73, and we get 11.4756. So we'll say about 11.5. So again, the moral of the story, anytime you're going to use one of those three buttons, sine, cosine, tangent, or the inverse trig buttons, first look in the mode. Part C, what is the distance between the bottom of the ladder and the wall? So in this part, we're interested in the bottom of the ladder and the wall, so that's this line segment here. I will call it X. Now that I have found Y, it turns out I could just use the Pythagorean theorem because we have two sides of the right triangle and we want the third side. We'll do that as well, but there are a couple of downsides. Number one, if we are using 11.5, this rounded number, then our answer that we get for X is going to have even more rounding error. So there's no reason to introduce new rounding error. Number two, we've been so focused on trig, well, let's just use it. So in this problem, again, we know the 73 degrees. We want the X, that's the adjacent side. We're going to use the 12. It's safe to use that because there's no rounding. So I've got adjacent and I've got hypotenuse. And the trig function that I want to use here is cosine. Cosine of 73 is adjacent over hypotenuse. X divide 12. Multiply both sides by 12. And we get x is 12 cosine of 73. We'll type that in here. One thing I want to do just while I have that number, I'm going to store this number right here. I'll call it y. So I just hit the store button down in the lower left. And to access the y, it's right here. It's above the 1, and it's in green on my calculator. So I first have to hit the green button. So I hit the alpha and then hit the 1. So that number that I rounded to 11.5 is now stored as y. Okay, so what we're interested in now is to find x, which is 12 cosine of 73. And we get 3.508. So around 3.5. And the reason that I wanted to store that number before, and the reason I want to store this number, I'll call this one x, because it's x, you can just use that main button just next to the green button. So I've got x and y stored in there. If I had chosen to go the Pythagorean theorem route, so just an aside here. So if you know that this is a 12 and this is an x, and we figured out this was around 11.5, then we can use Pythagorean theorem. X squared plus 11.5 squared equals 12 squared. X squared plus, let's see, 11.5 squared. I think that's 132.25. We'll check that. 12 squared is 144. And then we need to subtract 132 from both sides. So what do we get there? Is that 1175? I think that's okay. And then we take the square root of 11.75. Okay, so since we're recording, better to be safe than sorry and double check my arithmetic. So first thing I did was 11.5 squared, and that's 132.25. And then we subtracted that from 144. And we got 11.75, and then we want the square root of that thing. So square root of, oops. So we want the square root of 11.75. And whatever we get here should be x. Now, we've approximated x to be about 3.5. So we type that in and we get, well, that's not too far off, 3.427. Compared to the right answer, it wasn't exactly 3.5. Remember, I stored it as x. So if we just ask it for x again, it still knows. And I would say, you know, like we're off by almost a tenth, and that's pretty significant. These numbers are kind of small. So again, that's one of the downsides I mentioned for using Pythagorean theorem. But if you use Pythagorean theorem in the right way, we actually can get the right answer, or at least as close to the right answer as our calculator is capable of giving us. Let's just go back to basics here. What we typed in, or looking at this picture, we had x squared plus 11.5 squared. But it wasn't really 11.5. It was something that I called y. So instead of 11.5 squared, this should have been a y squared. And so then instead of 11.75, it should have been 144 minus the y squared. So I'm just going to type that into my square root. So let's see if we can do this right here. So we wanted the square root of 144 minus, and then to get the y button again, we hit green, and then 1, that guy squared. And the value of y, remember, we had stored before, so that had all the digits the calculator showed us plus some more. And you can see it's perfect compared to the answer that was right up above, which we got using trig.